Okay, so in the walking talking mock we got as far as question 11, which is a cumulative frequency question, and we did part A and we filled in the cumulative frequency table. We drew the cumulative frequency graph, and from it we read off the median, the lower quartile, upper quartile, and from it worked out the interquartile range. So that's where we got to. We now come to part B. So part B, stateside also investigated how long this group of 80 people spent watching television last Thursday. They published the following statement. Last Thursday, 80 people answered our survey on how many minutes they spent watching television. We now know the median time was 310 minutes, the lower quartile was 200 minutes, the upper quartile 560 minutes. The person who watched the least TV spent 50, and the person who watched the most TV spent 800. And the command, the question, is telling us to draw a box and whisker diagram to illustrate this information. So we drew a sketch of this on the formula page right at the start, and if you recall, what we are looking at for a box and whisker diagram is something that looks like that, where that was the min, that was the max, that was the lower quartile, upper quartile, and median. So if we just transfer from here that information, so the median time was 320, so this line is going to appear on 320. Lower was 200, so that line is going to appear on 200. Upper quartile was 560. And the person that watched the least spent 50, and the person who watched the most spent 800. So that's a little sketch of what we need to produce, and here's the paper for us to produce it on. And in this particular question they've given us a scale. Sometimes it's blank and we've got to work out what the scale is. So this is a little bit easier. If we just put on our boundary points there, the first one is the minimum at 50. So if I just 10, 20, 30, 40, 10, 20, 30, 40, 50 is there. So if I just put a little dot, a little cross there to mark 50, and then if I just, so I know that everything's happening on the same line, and I'd do this in pencil if I was you. Okay, so we're going to mark our points along that axis there. So we've got 50 for the minimum. Then the next point is 200 for the lower quartile. And for the box, it just needs to be symmetrical about this line. It doesn't have to be a certain size. So I'm going to count up 5 squares this way. 1, 2, 3, 4, 5. And 5 squares down. 1, 2, 3, 4, 5. So that's the lower quartile. Smudged a bit because of my pen. So that's the lower quartile. Then we've got the median on 320. So 300, 310, 320. So that's the median. Then the upper quartile is on 560. So if I count in 40 from 600, 10, 20, 30, 40. And the maximum is at 800. And now if I just draw the lines in, so that's top line, this line needs to go between the maximum and minimum. And there you go. So that is the box and whisker plot for 4 marks. Now the way the marks are awarded for this, there's actually 1 mark for having the correct shape. So just a little sketch up there, even if you couldn't draw it accurately, with the shape and the values on, would have got you 1 mark. The other 3 are for 1 mark for getting your maximum and minimum values in the right place, and then 1 mark for the correct box, and 1 mark for the median in the right place. So 1 mark for the general shape, so you're showing you actually know what a box and whisker plot looks like. 1 mark for max min, 1 mark for the box, 1 mark for the median. So that should be a nice straightforward 4 marks there. Part 2. Stateside 3 considers the results of the 2 surveys of the same 80 people. The manager of Stateside 3 states, I think people are watching more TV on a Wednesday night than on a Thursday night. Do you agree with the manager of Stateside 3? You must explain your answer with reference to the median and interquartile range for both days. So what this one is showing us is that the median, so on average, people on a Thursday night, which is what this one is showing us, spend 320 minutes watching TV, whereas on a Wednesday night, on average, they're spending 160 minutes. So they're spending twice as much time on the Thursday than on the Wednesday. So you don't agree because on average, and then we're going to say in brackets median, because that's the average we're talking about, people are spending 320 mins on Thursday compared to 160 mins on Wednesday. Okay, so we don't agree because of that. And then when we're looking at the interquartile range, if you remember when we talk about box and whisker plots, each part of the box and whisker represent a quarter of the data. So a quarter of the people watching are watching between 50 and 200. A quarter of the people are there, a quarter of the people are there, and a quarter of the people there. So half the people are watching between 200 minutes and 560 minutes. So the range there is 360 minutes. So also half the people, which is the interquartile range, are watching between 200 and 560 min on Thursday compared to between, and if we look at our upper and lower quartile on the Wednesday, it's between 110 and 240 minutes. So this is talking about the interquartile range, that is talking about the median. So the marks there, there's 1 mark for an argument that you're disagreeing, there's 1 mark for what you're talking about with the median, and there's 1 mark for what you're talking about with the interquartile range. Okay, question 12. 3 boxes of heights of 20 centimeters, 30 centimeters, and 40 centimeters measured correct to the nearest 10 centimeters. So that is crucial, okay, that you pick that up. Is it certain that they could be stacked on top of each other on a shelf with a clearance space of exactly 1 meter? Now this is one of the last questions on the paper. So it's a grade B question. A grade B question isn't going to expect you just to say, well, if I add those up I get 90 centimeters, so it's obviously going to fit in a space of 1 meter. This is crucial. When you read this, it should trigger maximum and minimum values when you're measuring. and that's what makes it a grade B. So 20 centimetres, if we're measuring that to the nearest 10, then to figure out its lowest value, if it was 17 to the nearest 10, it would round to 20. If it was 19, it would round to 20. If it was 16, it would round to 20. If it was 15, it would round to 20. But anything below that would round to 10. So the minimum value that that box could measure, it could be as small as 15 centimetres. And then in the other extreme, if it was 21, it would round to 20 as the nearest 10. If it was 22, it would round. 24, it would round. And this is the bit that people get confused with, is that we actually use the upper limit as 25, even though we know that would actually round up to the next one. So when we're rounding to the nearest 10 centimetres, something that's written as 20 could be as large as up to 25 and as narrow as 15. And then we could do the same for the 30 centimetre box. That could be as big as 35 and as small as 25. And the 40 centimetre box could be as big as 45 and as small as 35. So what we're doing here is we've got this gap which is exactly 1 metre. Well, 1 metre is 100 centimetres. And that's exact, so that hasn't been rounded. The worst case scenario with these boxes is if they're all at their maximum height. So if boxes are at max height, then they would be 25 plus 35 plus 45. And if they were all stacked together, we'd have 10, 15, 4, 5, 105 centimetres. So if they're at their maximum height, they could be as high when stacked together as 105 centimetres, which is greater than that gap. So not certain, because they could measure up to 105 centimetres when stacked. So that's why it's a grade B question. You've got to go looking and be suspicious about something in the second half of the intermediate paper which looks too easy. So for these 3 marks, there's 1 mark if I can see anywhere that you're working correctly with some maximum and minimum measurements. Then there's a method mark if you're correctly taking the 3 maximum values and adding them together. And for the answer mark, you need to have the 105 and conclude correctly why that is. Question 13. Derek buys a brand new car for £25,000. In its first year, it loses 10% of its value. Every year after that, it depreciates by 2% PA. PA means per annum. So every year, depreciate means it's losing money every year. How much can Derek expect to sell the car after 2 years of ownership? So this is a compound percentages question. You need to be able to deal with, and we've revised, a calculator allowed method and a non-calculator method. For this one, we're on a paper one, so it's a non-calculator method. So at the start, it starts off worth £2,500, and then in the first year, it loses 2% of its value. So 1% of 25,000 we divide by 100, leaving us £250. So 2% is going to be £500. So at the end of year 1, the value will be what he bought it for, 25,000 less £500. So it's going to be worth £24,500. I just realised I've missed part of this, haven't I? Sorry, in the first year it loses 10% of its value, not 2%. So if I just start this again, so first year, just goes to show you need to read the question carefully. 10% of 25,000, you're going to divide by 10, is £2,500. So at the end of year one, the value will be 25,000, and then because it's losing money, we're subtracting, and we're subtracting £2,500, which is £22,500. So at the end of the first year, that's how much it's worth. Then in the second year, now it's depreciating by 2%. So 1% of 22,500, which is its value at the start of the year. So if we divide that by 100, we get £225. So 2% will be double that, £450. So at the end of the second year, so in the second year is losing £450 of value. So at end of year 2, at the end of year 2, its value will be 22,500 less £450, which is going to be £22,050. So these compound percentage questions, sometimes they can be increases, like if it was going in the bank account, in which case you'd find the value and add it on every time, or it could be losing money, in which case you find the value and subtract every time. There's 4 marks for that question. So there's 2 marks, method mark and an answer mark for getting to the value at the end of year 1, and then a method mark and an answer mark for getting to the value at the end of year 2. And then the final question on the paper, and here once more you need to be mindful of where you are on the paper. It's the very last question, so it's going to be grade B, so it's going to not be a straightforward percentage question. The price of a computer inclusive of 20% VAT is £720. Find the value of the computer exclusive of VAT. So inclusive means the VAT has been added, and exclusive means what was its price before the VAT added. So that means that this is a reverse percentage question. We've been given the output, we know what it's worth after, and we want to go backwards to find out what it was worth before. So this has been increased by 20%. So the percent multiplier, the original is 100%, and it's gone up by 20%. So our multiplier is 120%. So 120% of 720, sorry, of the original, what we're trying to find, is 720. So just like with the previous question on compound percentages, this is one that we show you a different method for non-calculator than if it's on a calculator allowed paper. So on a paper one, this is what you do. 120% of something is £720, and what we want to work out is what 100% of it is, what the original was. So the way that we do that is, first of all, we find 10%, and to find 10% we need to divide by 12, because 120 divided by 12 is 10%. So 10% of the something, and if we're dividing that by 12, we have to divide the output by 12 as well to maintain the balance of the sum. So to find 10% we divide by 12. If that was 140% we divide by 14. If it was 80% we divide by 8, and so on. When we divide this by 12 we get 60. 12 sixes are 72. So 10% of it is 60. I don't want 10%, I want 100%. So 100% of the something, to go from 10 to 100, I've now got to multiply by 10. And if I multiply that by 10, I have to multiply that by 10 as well. So 100% of the something, which is its original amount, is 600. So computer cost £600. So that's just a method you've got to learn, and something that you have to spot in the second half of the paper. So the marks for that, there's a mark if we spot you using the right multiplier. Then there's the method of breaking down from 120% to 100%, and an answer mark for getting the correct final answer. So that's it. Those are the last couple of questions that we didn't have time to complete in the hall yesterday. Hope you find that useful.